So welcome to this session on leveraging WebRTC new features. I'm Bernard Aboba, and our goal for today is to introduce you to shipping features of the WebRTC standards. It's actually been a momentous year for WebRTC because starting in January of 2019, the elements of the WebRTC 1.0 candidate recommendation, such as add transceiver and unified plan, were turned on by default in Chrome and later in the new Chromium-based Edge. They'd already been the default in Firefox, and they are now the default in Safari. In addition, Chrome and Firefox also now implement the W3C screen capture APIs, as well as it's now Chrome, Firefox, and Edge Beta in that category. So the first step towards leveraging new standards is to read them and know everything you need to know to write a WebRTC application. And here are some links to the latest documents, and they're in a number of categories. People think mostly about WebRTC 1.0, but there are also a number of other standards that you need to read to fully understand the system and the context. That includes WebRTC stats, which gives you the statistics metrics. That spec has been completely revamped in the last year and will be recycling very soon at candidate recommendation, hopefully very close to its final form. WebRTC 1.0 is currently recycled at candidate recommendation. We're looking to bring it to proposed recommendation sometime in 2020, and that means demonstrating some of the implementation as well as interoperability, and I'll show you where we are based on some of that evaluation criteria today. We also have media capture and streams, which I think is probably the most mature of all the specs. It's been recycled at candidate recommendation, and aside from privacy issues, is on its way to proposed recommendation. Screen capture is among the less mature. It's only a working draft at this point, even though it's been implemented. I think that's mostly a procedural matter to bring it to candidate recommendation. As far as I know, there aren't many serious interoperability issues, although we may need a few more tests. We have audio output devices, which is a candidate recommendation. It's in Chrome and Edge Beta, has not been implemented yet in Safari and Firefox. There are a few privacy issues there, but hopefully we can bring that to PR. And then a few other things like media capture from DOM elements, media stream recording, which does have some significant issues left and is only a working draft at this point. So there is significant work to do there. And then content hints, which is an editor's draft in Chrome and Edge Beta, and I'll be talking about that. That one is particularly important going forward, and I'll describe why. And then there are a few other specs that have completed an origin trial. We've been working with Quick, so we did an implementation of peer-to-peer quick data exchange in Chrome and Edge Beta. That was during the summer. We'll probably have another origin trial in 2020 relating to Quick. Clients probably more oriented towards the client-server web transport. And then there are a bunch of specs which aren't implemented yet, but we're hoping to make progress on. There's the DSC control API, you know, the old saying that QoS is great for PhDs, but not so much for applications. I think we're proving that correct here. We don't really have any prospects for implementation of QoS within WebRTC, but hopefully we can find something that would work. The web transport, which I mentioned, the WebRTC SVC, there is an intent to implement statement on that, and I'm hoping that we will get movement on that in 2020. It's particularly important for AV1 to be able to utilize the AV1 SVC modes and as well as the VP9 SVC modes, at least in a standardized way. And then we have WebRTC ND use cases, which isn't something you'd really implement, but it's just trying to articulate what we're trying to do for the next generation of WebRTC. So let's talk a little bit about where we've come with WebRTC. Jan-Ivar Brewery of Mozilla has written an excellent blog describing the 3 different APIs that we've gone through since the conception of WebRTC in 2011. The first was the add stream, remove stream API. That has been widely implemented, and it had a number of issues which I'll be talking about, but among them was that it had widely varying SDP dialects, you could say, Plan B versus Unified Plan. That and other issues relating to the use of media streams instead of tracks, which I'll talk about. It is no longer included in the WebRTC specification, which actually, frankly, I think was maybe not the greatest decision. because taking it out doesn't really make its specification any more clear. And people have written a lot of applications to it, but we removed that API. So, actually, the second one was the add track, remove track API, and I'll be talking a little bit about more. That is also widely implemented. That also has widely varying SDP dialects between Plan B and Unified Plan, but it does have some objects in it. The RTP sender and RTP receiver are supported. And you can do a few things, although not everything you can do with the third and final API, which is add transceiver. That is the favored WebRTC 1.0 candidate recommendation API. It is required to be implemented. You have to implement Unified Plan to do add transceiver. You can't do it with Plan B. So essentially you get both a different API as well as a different SDP dialect, but hopefully one that's more uniform. So we've ironed out some of the SDP differences, although they still exist. And you get a full object model and a number of advanced features such as simulcast and direction and things like that. So fairly big change. I think the biggest change of all of these has been the move from add track, remove track to add transceiver with all the things that come with it. So why is there an object model? Why did we make the transition from add stream, remove stream to add track, remove track in the first place? And why wasn't that sufficient? Well, the first issue is that when you were operating on media streams, you didn't have a good way to tweak parameters on individual tracks. So in other words, you might want to apply things like max bit rate or max frame rate or direction differently to audio and video. And when you're operating on a media stream that had both audio and video, you couldn't really do that well. So we had to go to the track level, not just the media stream level. The other thing was the control services weren't adequate to do what we needed. So you wanted to be able to do things like modify what would come out of create offer, and that was really needed to be done on a per track basis rather than a media stream basis. So you might, you couldn't really have parameters relating to add stream. We found developers were doing things like adding tracks to their media streams and then wondering why they weren't coming out the other side. And that was because they weren't doing the negotiation phase. But they just thought adding to the stream would somehow make something magically happen, and that wasn't working. And then the media stream track constraints by themselves, they only affected raw media. They didn't affect encoding. So you couldn't do everything you needed to do just with constraints. Things like simulcast really demanded encoding parameters as well. So these are some of the reasons we went to a track-based model. And that was where we came up with add track and remove track. And it seemed like that would be all we'd need. We moved to the track-based model. But unfortunately, we had very big differences in SDP. Chrome had Plan B, and that was also implemented Edge, whereas Firefox did Unified Plan. And we did have the sender and receiver objects, but we didn't have the other objects there. And for that, we needed Unified Plan. So ultimately, we ended up with add transceiver. And one of the other problems with add track, remove track was that an M line is really both a send and a receive concept. So with add track and remove track, it was sometimes a little tricky to figure out what sender went with what receiver. But when you do add transceiver, you get both a sender and receiver, and you know that they're paired because you also have in that object, you have the M line that connects them. So it's a little bit cleaner that way. And finally, because you have to implement Unified Plan to do add transceiver. You can't really do it without it. You get more uniformity in the SDP. And as a side benefit, you also get the object models along with it and some of the advanced features that come with that, such as simulcast and direction. So anyway, that is the theory behind why we ended up with 3 APIs. Now, of course, for the developer, it isn't all fun and games because you've gone through these 3 iterations. And at each stage, of course, you have to not just implement them, but fix bugs and make it all workable as a system. And we're still in the middle of that, as I'll describe with add transceiver. Hopefully a little bit more than the middle, more like 80% done, hopefully. But so add transceiver was first implemented in Firefox 59. It's now available in Chrome since January. I mentioned it's the default, and we've had simulcast support in M73 since M73. And as I mentioned, it creates an RTC transceiver object that has both a sender and receiver pointer within it. And as part of this, you can allow the sender to be initialized with send encodings. So that is useful, for example, if you want to start sending simulcast, you can put these multiple encodings in the send encodings and start off that way. That establishes what we call a simulcast envelope, the maximum number of simulcast streams that you can send. And then the rule is you can turn the simulcast encodings on and off using an active attribute, but you can't add more. So if you start with 5 simulcast streams and it's accepted, then that's the maximum you can have. You don't have to send 5. You could start by sending 3, and then you could add or disable. But you can't go from 3 to 5. You can't go the other way. And one of the issues that we had when we went to add track, remove track, is that people were very used to, in the add stream, remove stream API, having something that tied together a send and receiver. And initially in add stream, remove stream, that was what was called the media stream identifier, the MSID. Now, when we went to add track, remove track, people got somewhat confused because the track ID didn't carry forward from one side to the other. The track IDs weren't aligned. But in add transceiver, we were able to fix that by at least offering developers the M line. The MID is the same on transceivers that are matched in the same M line. Now, developers are still pretty mad from what I've heard about that change, haven't really recovered from the MSID, and I'm not clear that they're entirely happy with the MID, but at least it's, like I said, that's our story, and we're sticking to it as to what we've done to help them correlate one side and the other side, is the MID is the answer. So Jan Ivar has written another great blog about this, about our RTC, RTP transceiver explored, where he goes over all the issues and exactly what happens when you do things on one side and how it's reflected on the other side. So great reading there. So at this point, this one OCR concept, add transceiver, is now in Chrome, Edge, Beta, Firefox, and Safari with Catalina. It's now there as well. So we have elements of the CR plus Unified Plan, the default in all browsers. Okay? And these are some pointers to the Chrome announcements and the rollout that began in January of 2019 and the transition guide that was issued there. Now, it's still possible to retain the Plan B behavior in Chrome, the old legacy, and frankly, as far as I know, a great number of large-scale shipping applications are actually doing that. They have not transitioned to Unified Plan yet. And you do that through a configuration parameter passed in the constructor to RTC peer connection, basically STP semantics Plan B. You can explicitly ask for Unified Plan, although it's a default. I guess that might make sense in older browsers, although Unified Plan probably wouldn't work on some of those older browsers anyway. So that's how you can get what you want. And if you have any questions about what a given browser is supporting, to know if you have Unified Plan, you really can't have anything other than Unified Plan. If you support add transceivers, you can just, one way is to just check for support of add transceiver. That pretty much tells you you've got Unified Plan if you have that method, if you have that object available to you. So you can do it that way. And if you want to do it a Chrome-specific way, which I wouldn't recommend, you can just do pc.get configuration and see if what your STP semantics attribute is set to, Plan B or Unified Plan.
Question?
Yeah.
I don't know if this is the right place to ask.
Sure.
Is this going to break existing web applications?
Well, so in January, there were a lot of panicked people who suddenly saw the default, because the default behavior changed, they started breaking. The old theory was if you're just doing one-to-one, everything should be the same. But basically, if you were depending on the semantics of STP, you probably got broken. And the advanced apps like that were doing simulcast also experienced damage. But since then, people have generally recovered by specifying Plan B there, and so that wasn't a horrendous thing. And most of them still aren't, most of those apps still are not completely converted to Unified Plan. But what I'm hoping to do with this talk is at least convince people that they should be working with Unified Plan and reporting bugs, so that eventually it will get up to the point where they can make the transition safely. I'm not claiming that this Unified Plan is suitable for public consumption yet. I'm just trying to make the argument that it's headed in that direction, and you should pay attention. Okay, so this is the WebRTC 1.0 object model, and basically, for those familiar with ORTC, it's got almost all of the objects of ORTC. You have basically the RTP senders and receivers that I mentioned that came in with add track, remove track, as well as a DTLS transport object and ICE transport. You have a data channel object which now has an SCTP transport that is attached to it. And basically all of these objects are now implemented in Chrome and Edge Beta. So the basic objects are there now for you to play around with. Now these are the portions of the specification that describe the behavior of those objects. And I will say that it is fun playing with the objects because you find that they don't always conform to the spec. Like in particular, I was doing some tests for this conference, and you'll see this in a little app that I wrote. I was looking at the spec, and the spec seemed to claim that the objects come into existence when you call set local description. That is not in fact the case, at least in Chrome. So you'll see, I'll show you an app, and there's a little error that I get when I try to find the DTLS transport after calling set local. The spec claims it should be there. It's not there. I'm not clear whether the spec is wrong or Chrome is wrong, but we're having an argument. It does relate, and this came up, in fact, when we were trying to implement rollback, and our developer came to us and said, well, what happens? What do I do with the objects? Do I kill them or not? And we looked at the spec and said, we don't know. So there's still a few little random things in there that need to be done, but the objects, at least when you call set remote, they do exist. When you are in the stable state, the objects do exist in Chrome. So here are all of the methods. It's a little bit of an eye chart. I won't go over everything, but basically along with all the new objects come a lot of new methods. And as I'll show you in a minute, many of these are in fact implemented. I'm not saying they're all correct, but most of these things are actually there. Certainly all of the peer connection, the new methods are there, the get senders, get receivers, get transceivers, add track, move track, add transceiver, and now the .sctp. Those are definitely all there. And then in the sender, you do have the track. The track attribute is there, and it seems to be functioning correctly. The transport object, which refers to the DTLS transport, that's the one I said was a little wonky. It's null in situations where the spec seems to say it should actually be present. We'll have to work that through. Chrome does implement get capabilities and get parameters. So I'll show you what that looks like in a minute. And you can set parameters. Do replace track to change the cameras. You can set streams is not implemented yet. That's actually kind of important for some of the stream behavior. But generally, most of the stuff is actually done or heading that way. So here are some of the classic use cases that you should be able to do with those objects. I say should because I don't think we have tests for all of these. We probably ought to have them, although some of them are the kind of things you can't just do in WPT tests. You would need like a kite test to test that all of these things are working correctly. So it probably would be good to make sure all of these things are actually working. But you can do things like sending simulcast. You cannot receive simulcast in any browser. I have that as optional, but it's pretty much nobody's taking the option. So you just assume that you're receiving a single stream, although you can send multiple. You can get detailed info on the state of the ICE and DTLS transports. The states do seem to be working and the events that are coming out of them. So that can give you a little bit more information if, for example, your connection state goes down and you're trying to figure out what happened there. And then you can set the maximum bit rate. Currently, we do not have maximum frame rate implemented in any browser, but at least you can set the max bit rate. There was some wonky behavior, I think, that came up in the last interop test that you did, Dr. Alex, but hopefully that is on the way to getting fixed. You can disable and enable send the media instantly. That's the active attribute. That does seem to work without signaling. Changing the camera source does seem to work like it's supposed to, replace track. And then changing the send codec. This is the set codec preferences. I'm not sure that works exactly as it's intended to. Need to do a little bit more testing there. So this is an example of simulcast with the WebRTC API, and there's this concept of the RID. You'll notice in the old Plan B APIs we used to have SSRCs. We don't anymore. We just have the RIDs. And I know, Lorenzo, you've written some good material on how to deal with RIDs only. Not everybody is able to deal with this situation right now, but hopefully the industry is moving in that direction where they can live without the SSRCs, parse the RIDs, and get what they need. I've got two examples here, one with scale resolution down by. That part is implemented. The max frame rate is not yet there. So you can't do simulcast with varying the frame rate as you would want to do, for example, in a screen share. So that's not quite there. I won't do this demo, but it's kind of fun to look at. It was done by Fitbo. It's called Simulcast Playground, and basically what he does is he's sending simulcast to himself. So I mentioned you can't receive simulcast, so he plays around with the STP to make it look like multiple streams coming in, and this is useful as an example of a test because you can send simulcast to yourself and then test whether these controls, max frame rate or max bit rate, are doing what you think they ought to do. So anyway, if you play with this demo, you'll see that max frame rate is still not connected because you can move it and nothing happens. And also, I'd like to have a note here that this does not use this add transceiver API. And the reason it doesn't is because this test relies on SSRCs to be able to send the stuff back to yourself. So there's actually a problem in that it would be nice to have a WPT test for simulcast. We can't write one. We can write one that runs on Firefox. This beta cannot run on Unified Plan as it is right now on Chrome. So a little bit more about the implementation status. What I'm going to show you here is just purely about what's been implemented and not implemented. I'm not going to be talking about interop. So this is just a question about whether somebody did something. And basically, this is a bit of an eye chart, but green is good. Green means that it's in basically 2 or more browsers. So this portion of it relates to RTC peer connections. So you can see that it's almost all green, with the exception of the .sctp attribute, which was only done in Chrome, get default ICE servers, which nobody has done, and on ICE candidate error, which we just checked into Chrome about a week or 2 ago. Yeah.
Don't call me down. Is that like
That's Dominique Hazelmasseux. He's the person who put this together. Yeah, he's our W3C management person. So anyway, so yeah, there are a few of these red features. So just to summarize it, basically, there's some features that haven't been done yet, but there is an intent to implement statement like max frame rate, so it's probably going to get done. But then there are a bunch of stuff that we call features at risk, which nobody has done and nobody seems to want to do. So those things may end up getting removed from the spec. Examples of that is get default ICE servers, get supported algorithms, which is for the cert, the encoding parameters, the DTX parameter there, and potentially peak time. So that's kind of a summary of it, and I'll give you a little bit more detail here. So you can see in the ICE candidate, the basics of the object are there, but some of the properties are not. Those are in red. They are actually in Chrome, but not in any other browser. And then, yeah, so you have the RTC certificate is there with the exception of get supported algorithms. And then you have the sender, and basically that's all there with the exception of the set streams method is not. It's done, actually, set streams is in Chrome, but it's not in any other browser. And similarly for the other stuff, for receiver, basically it's almost all there. Transceiver, the same with the exception of the stop method, which has proven itself to be a little bit problematic. We're still working that through to get that done. And then basically all the other objects are in Chrome at this point, not in other browsers, but they've gotten into Chrome. And then basically this is more the data channel. The thing that's in red down there is RTC error. So we actually have implemented the basics, but we have not hooked it up, so you can't get the extended error info yet for things like DTLS alerts. So here are a few coming attractions. These are the intent to implement statements, which show up on BlinkDev. It's worth reading because it gives you an idea what we're working on, what's coming. Most of the things there are going to get filled in, with the exceptions that I noted. Things like get default ICE servers have no intent. So just a little bit more about the evolution of screen sharing. It's there. It pretty much works in all browsers. I say it works in Safari, but actually I was testing it on Catalina and it doesn't. And I'm kind of don't understand why. I thought it was in process, and we have all the code. Yeah, you can. That's true for all browsers. For Safari, I can't seem to. The permission doesn't ever get accepted. Yeah, you need OS level, but I got it working for everything except for Safari. So, and I'm told that somehow it didn't get enabled there. So anyway, not particularly complicated. And the last thing I want to talk about is content hints. This is very important if you're going to do screen sharing, because what it does is it optimizes the screen share for the kind of screen share you're doing. So in particular for the video, we have a couple of things. Motion, which is like you would use for sports. We have detail, which is for like a PowerPoint, and then text, where you want the text to be readable. And with AV1, what this should do, Alex, is the text should turn on the screen coding functionality of AV1, and that will potentially dramatically improve the compression for things that need it. Anyway, that's it.